There is a specific kind of freedom you only feel thousands of feet in the air. The rush of wind, the sharp bank through broken clouds. It's an experience rooted entirely in the physical world. Before she was exploring the mathematical architecture of the universe, Sabrina Gonzalez Pasterski was a 14-year-old girl building a single-engine plane from a kit. Constructing that aircraft required an intense focus on strict physical constraints. She had to master the layout of engine instruments, calculate exact fuel levels, and monitor oil pressure to keep the machine airborne. Learning exactly how parts fit together to achieve flight trained her to think like a builder. That deeply mechanical mindset became the crucial tool she would later use to take apart the invisible mechanics of reality itself. But there is a limit to what you can accomplish with metal and fuel. To grasp how the universe actually operates, you have to look past physical engineering and step into a realm where the forces at play are completely invisible. Sabrina eventually traded her aircraft manuals for textbooks on the fundamental laws of nature, leaving aerospace engineering behind to become a theoretical physicist. Her rise in the field was rapid, marked by research fellowships and ceremonies where she shared the stage with global icons like Simone Biles, signaling her move into a level of physics that only a few hundred people worldwide are currently pursuing. For a builder like Sabrina, the next logical step wasn't about the plane, but the medium it moves through. To understand the environment containing the aircraft, she had to move beyond the machine and investigate the geometry of space itself. That interrogation brought her here, to the Quantum Fields and Strings Group at the Perimeter Institute for Theoretical Physics. As a lead researcher, her team is tackling a massive theoretical framework known as celestial holography. The celestial half of that concept is straightforward. It is the physical, three-dimensional universe you observe when you look up at the night sky. This illustrates the holographic principle. Quantum gravity, the force governing how matter interacts, can be understood as a lower-dimensional theory. Watch as the particles inside push outward. The complex data of our three-dimensional universe is encoded entirely on this flattened two-dimensional outer boundary. Physicists are not using this as a visual aid. They are mathematically attempting to prove that the sprawling, infinite cosmos is structurally a giant hologram. The problem is that holographic principles are usually reserved for highly controlled theoretical models. Sabrina's team has to force this math to apply to the messy, real-world universe we actually live in. They start with this representation of standard spacetime. The first step is removing the cosmological constant, the energy density causing the universe to expand. Without that expansion force, the curved space snaps tight, creating almost flat spacetimes and stripping away the curvature of gravity. From there, the geometry drops perfectly onto the surface. The goal is to successfully map the distinct physical features of our real universe onto this rigid, infinite, two-dimensional schematic. She is still approaching problems the exact same way she did in the hangar. She is simply reverse engineering a three-dimensional universe instead of a Cessna. Reverse engineering the universe is a task that defies individual timelines. A kit plane takes roughly 2,200 hours to complete. Mapping the structure of reality is a project that spans generations. For decades, the culture of theoretical physics encouraged a solitary, cutthroat environment where researchers fought the competition to secure solo prizes and individual prestige. Sabrina recognized that applying that same competitive pressure to a problem as vast as quantum gravity is an incredibly inefficient way to work. At Perimeter, she champions a different strategy. They take an orthogonal approach, actively abandoning the solo race to embrace deep, cross-disciplinary collaboration. By talking through ideas and weaving separate theoretical models together, multiple distinct lines of thought converge. It is the most realistic way to break through the dense mathematical roadblocks of flat spacetime. It goes right back to the aircraft builder's mindset. You rely on previous engineers' manuals, use parts manufactured by others, and build upon shared knowledge. The physical universe might ultimately turn out to be a lower-dimensional projection, but proving it requires a community, participating in a long, shared human legacy where knowledge becomes powerful exactly because we build it together.